Hey, you. What is that?
These? Man, you know I never leave the house without my gas laws. So first law we got is the ideal gas law, and that's PV equals nRT, or as I like to say, inert. And so, of course, the P stands for pressure, V stands for volume of the gas, equals, N is the hashtag or numbers of moles, R is the gas constant. I don't really know what that is, but it's the gas constant. And T is the temperature of the gas. So, a rigid seal cylinder with a volume of 20 liters is filled with helium gas to a final pressure of 1,520 mmHg at 27 degrees Celsius. How many grams of helium does the cylinder contain? Okay, so since we're looking for grams, we're gonna get N by itself. So we're gonna take out our T, we're gonna divide it on both sides, and then cancel these out. So we're gonna start off with N equals, the pressure is 1520 mmHg times the volume, which is 20.0 L liters, divided by the R, which is the gas constant over here, mmHg over mole times K, which is Celsius. Or not Celsius, Kelvin. Last thing we need is our temperature, which is 27 degrees Celsius, but you need it in Kelvin, so you're gonna add 273 to 27, and that equals 300. So we have 300 K. So since we're trying to get moles by itself, we're gonna take out everything that matches. So taking out liters, mmHg, and Kelvin. So this will equal 3,004 over 18. Oh, that's wrong. It's okay, no matter. 720. So that ends up equaling 1.62. But since we only have two sig figs, it goes down to 1.6 moles. So now to get grams, we're going to do stoichiometry. We have 1.6 mole of He. To get down to 1 mole has 4.00 G of He. This will equal 6.4 G of helium grams. Second gas law we have is the combined gas law, which combines Charles Boyle and Gay-Lussac's laws of gases. Anyway, there's two equations, two different ways you can write this. First one is P1, which means pressure, volume 1, which means volume, and temperature of the second gas, which is temperature, equals pressure 2, volume 2, and temperature 1. Second way to write it is pressure 1, volume 1 over temperature 1 equals pressure 2 times volume 2 over temperature 2. 2 liters of gas at 35 degrees Celsius and 0.833 atm or atmospheric pressure is brought to STP. What will be the new gas law? So our first pressure is 0.833 atmospheric pressure, or atm. First volume is 2 liters. And our second temperature, which is temperature at STP, that would be 273 K. Equals 1 atm. We're still looking for volume 2, so we're just gonna leave that out. Temperature 1 is 35 degrees Celsius, but we need to change that to Kelvin, which would be 308 Kelvin. So together, this equals 454.818
ATM times liters times K equals 308 ATM times K. But we're still looking for volume 2. So we just leave that out. We're going to divide this 308 ATM over K times K, whatever. Divide it, same thing over here. 308 ATM times K. Take, cross out what matches. We're left with liters. So altogether, that would round to 1.48 liters. But since we were only using 2 sig figs, we're gonna go down to 1.5.